Today we explore how the analytical question of the 647 Palindromic Substring. And in this topic, we will have a string and we have to return all the palindromic substrings in it. And palindromic, it means that you see it reads the same backward as the forward. And substring, which means part of the string. So for example, like here, A is palindromic substring because it is a substring, and also write as the palindrome rules because A is A, B is B. And for example, like here, AA is also the palindromic substring, and also AA here is palindromic substring. So we have to find all the possibilities, all the palindromic substring here in tree. And here I already have a solution which use the brute force, and then I will show a more efficient way later, but we can see it as brute force first. In this part, we have a function called check palindromic, and then we use two for loop to get the star of the string, and then use the second loop to define the end of the substring. So star and end. So for example, like here is AB, and then the end will go to C. So it's AB or ABC, and we will check it, and we will put this star and index into the function. And in this function, we use star and to cut the string and then reverse it. So it's very simple to understand because Python's string, you can cut the code into the index to check directly. So it look forward from start to end, and you look forward from end to start because here is the reverse. So if you look forward and you look backward, it's the same, we return true, and if not, we return false. So we just use two for loop, put star and end index into the function, and then if the function of the check palindromic return true, we can put this result into our result list, and then we can return the length of the result. This is just a brute force way, and then we can make it better. So the second way I would like to use is, because all of string we can see is part or event, so we can put every index into check its left and right to make sure it is a palindromic or not. So in this way, more efficient way is we only use one for loop and then put into the function to check is it palindromic or not. So but this time, this check palindromic will left, well, -1, and right, well, +1 every time. And then we use the iteration, we use a for loop to go through every character in the string. And then we just spaghetti, we put every index into the palindromic function, and then make sure if this index is the center of the palindromic substring, the next step is make the left -1 and make the right +1, and then we can check step by step. And this function is good because this way is good because if it is not a palindromic substring, we can block directly and stop there. We not necessary to check all the possibility of a substring. So firstly, we need the length, because then of the string we will use many times, so we can just make it. We can count it first, and then in this case with the two scenario, it's odd and even. Just call it left and right. And if there's odd, the center of the index will be the same. Left and right index will be the same. So, okay. And then for the even is what we put into the function check palindromic function is the center, also the next index of the center. So that's one. And then in this case, we will check. So important, right? Also, that be bigger than 0, right? So unless it will be out of index, and right should be smaller than that. Let's make sure this 2 is just to make sure our index is not out of index. And then so here we should use while because it's the if and for loop. And then we can count. We should count. And then so if minus. So if this three conditions match it, we have to go to the next step. So is the left will be -1 and right will be +1, and then count should be +1. Count here is to check if this left, if this, for example, like B here is this index is in the center, and then if it is a palindromic substring, the count will count 1 time, and then we go to the next step. So next step should be the left and right, and then we check A is not equal to C, so we will not count again. So this count, if B is in the center, the odd only count one time, which means only B is the palindromic substring, and that's right because only B is palindromic substring and ABC is not a palindromic substring. We should return. So odd and even will have this count. We need a result to. So if odd is odd, if odd is bigger than 0, which means when any index is in the center and it happens any palindromic substring, we will count it into the result. Some object if event has the number, we will put event into our result, and then we have an result. So I think the problem is we should put this condition before the compare scenario to make sure every index is not out of index. So here, hot arrow down, also wrong time, that, and then we can submit. Wonderful. So we got a time complexity, although it's n. It's also wrong 2 times of for loop, but in this for loop we use very smart way. We only compare the left and right number and not compare the center again, and keep going the left to the more left and right to the more right, and we just compare these two biggest number, the left number and the new right number, and we have a very good time complexity, and we have very good spec complexity. Thank you. So today we just use a smart way to solve this problem.